Barry Clark, Dr. Barry Clark, he's been involved for 32 years in marine biology research and consulting, especially in coastal and marine zones and issues. He works as a scientific researcher, lecturer, consultant, and he has experience in a tropical, subtropical, and temperate ecosystem. So he's quite well exposed to all of that. He's presently the director of the environmental consultancy, Anchor Environmental, which is the consultancy that we employ to do most of our testing. And he's also a research associate with the University of Cape Town. As a consultant, his primary concerns is conservation planning, monitoring, assessment, and human impact on marine areas. And as far as I've read, you always see Barry's name: Berg River, St. Helena Bay, Saldanha Bay, Richards Bay. So it's an honor to have you here, and we look forward to this results and where our bay is going. Thanks, Barry.
I have got something. Is that working? I can hear it now. Okay, good morning, everyone. It's a real pleasure to be here. I've been working with the Saldanha Water Quality Trust for, nearly 25 years now. And it's always a great honor to come here and present on the current state of the bay, from the work that we've done for the trust. But before I go any further, just to emphasize, this is not my work. It's a work of a very big team that I work with. I want to acknowledge all of the people who have helped over the years and specifically this year in producing this year's State of the Bay report. Can I go to the next slide? Those of you familiar with the State of the Bay program, it's an annual assessment of anthropogenic impacts on the bay and of the health of the bay itself. In terms of anthropogenic impacts, we talk about activities and discharges that affect the health of the bay, and I will give you some insights into what we've seen changing in the bay in terms of those activities and discharges. But also we look at both the physical health of the bay and the ecological health. Physical health, I'm speaking about parameters that water quality related parameters like temperature, salinity, waves, currents, groundwater flows into the bay. And then the ecological health, we're looking at the abundance and really the abundance and the community structure of the living organisms that occur in the bay, from the seaweeds through to the little invertebrates, the birds, the mammals, the fish. And Simon has told you quite a lot about mammals. I'm going to focus mostly on some of the other smaller organisms and animals that we find here. Next slide, please. Okay, we look at a huge range of different indicators and parameters in the bay because they all respond at different time scales, and it gives us an idea of how things are unfolding over time. When we look at water and sediments, the physical parameters, they tend to respond very quickly. If you have an oil spill or a spill of some chemical spill, you pick it up very quickly, and changes in the water quality, that slowly percolates down into the sediments where some of the contaminants tend to accumulate. And then the living organisms that live in the sediments or in the water, they take slightly longer to respond because their life cycles are long. And the smaller organisms, the ones that are short-lived, like the little macrofauna, tend to respond in weeks or months. The longer-lived organisms, the fish and the birds, tend to respond a bit longer. And of course, the ones that take the longest of all are the big marine mammals, where their life cycles are 40, 50 years. So by looking at all of a range of different indicators, a range of different parameters, gives us an idea of how things are changing over time. Next slide, please. And then we integrate all of that information, and it tells us something about the health of the bay, and we try to simplify that by ranking different aspects, different elements of the bay into natural, good, fair, or poor categories. Natural, we say there's little or no change from natural. Good, we see some small alterations, but things are largely carrying on as normal, as they always did. Fair, there's been some significant changes, and things are starting to unwind. We're starting to see a dominance of tolerant or pioneer species, and our sensitive species are getting lost. And then you go through to a condition where we say is poor, where we've seen extensive change in the physical environment. Most of the sensitive species are lost, and you're seeing mostly only pioneer or those very tolerant, pollution-tolerant species. So you'll see those smiley faces coming up in various places in the talk where I consider different aspects of the health of the bay, and then we try and look at it holistically at the end and talk about the health of the bay as a whole. Next slide, please. Big thank you to our sponsors here. The work that the Saldanha Bay Water Quality Trust does is I think, hugely important. It costs a lot of money, and thanks to these people, mostly industrial or industries or people that are operating around the perimeter of the bay here, also government authorities, Transnet, Saldanha Municipality, who contribute financially to the trust every year and make it possible for us to do the research and to bring these results to you to keep you up to speed on what's happening here. Next slide, please. Also, very important thank you to those people that contribute data and information on the health of the bay. We don't do all of this work ourselves. There's an enormous amount of monitoring that goes on in and around the bay, and by various different government and academic agencies, organizations, research agencies, government agencies around the country that do work here, and they contribute data to us that we incorporate into the State of the Bay reporting system. So a big thank you to all of those people as well. Next slide. I always try and have a kind of focal area or a specific theme for each of these State of the Bay reporting sessions. This year I want to focus on alien invasive species. For me, a very important topic, and it's something that we're beginning to understand much, much more about, because we've had a huge increase in focus on alien species here in Saldanha Bay. With the help from Anglo American and Kumba Iron Ore, we've now getting a much better idea of the importance, the impacts, and the significance of alien species here. And this is specifically marine alien species. And I will touch on more on that towards the end of the talk. Next slide, please. Okay, so I've structured the talk. Firstly, I'm going to speak a bit about activities and discharges. I'm not going to speak about all the information we used. I'm just going to cherry pick certain key interesting items, and then I'll move on to looking at the physical health of the bay, the physical elements which we've been monitoring, and then finally the ecological health. From an activities and discharge perspective, there's a lot of development pressure here in Saldanha. Saldanha is one of the few natural sheltered big embayments on our coast. It's an important port. There's a lot of industry concentrated here, taking advantage of the sheltered waters the bay offered for movements of goods in and out of this country. We did see a few years ago that development pressure was definitely on the way down, or went down quite significantly during the global economic financial crisis, and then followed by COVID. Really things slowed down a bit, but we seem to be coming out of that quite clearly. And in terms of pressures on the bay that I'm seeing going up in the last year is some of the ore exports going out of the bay that are definitely clearly up: manganese, zinc. We're seeing increases in shipping traffic here, and you understand from what Simon was saying the importance of that. Increasing residential development, and with it stormwater runoff going into the bay, and I'll talk a little bit about some of those impacts now. Mariculture production is increasing, and there's lots of new projects on the horizon here. You heard about green hydrogen and ArcelorMittal just now. With that, we need reverse osmosis plants to provide the fresh water, both for industry and also for people that live here. There's increasing LNG, liquefied petroleum gas and liquefied natural gas that is imported into Saldanha Bay. There's always ship repair activities going on here. Something that's coming fairly new now is in-water hull cleaning, which is, for me, a big risk from an alien species perspective, and I'll talk bit more about that later. Floating storage regasification units is something on the horizon, and power ships, also something that potentially we'll see in the Saldanha in the future. On the downside, numbers of tourists, numbers of visitors to Saldanha Bay and Langebaan Lagoon have gone down quite significantly over the last few years. Something that concerns me a little bit, and I'll talk about that now. On the positive side, effluent from some of the wastewater treatment works here have gone down, which is really great. Some of the ore exports are down, iron ore and lead exports are down, and ballast water discharges are also down quite significantly, which is contrary to what I would expect with an increase in shipping traffic, but I think it's the nature of the vessels that are visiting Saldanha Bay that are changing, that's leading to that changes in ballast water. Next slide, please. I said I would talk a bit more about visitor numbers. We've got information on numbers of tourists or visitors to Saldanha Bay, Langebaan Lagoon, based on stats collected by the West Coast National Park. We assume that total number of visitors to the Saldanha Langebaan region are probably closely linked to the number of people visiting the West Coast National Park. We've got data from 2005, 2006, all the way through to the present day. Very nice increasing trend up till about 2016, 2017. Numbers nearly doubled over that period from around 100,000 visitors per year, tripled to around 350,000 people. And for some reason started declining in 2017, 2018, and went down quite dramatically during the COVID years, 2019, 2021, but seem to have continued declining. The different colors in the graph here are the different categories of visitors. Paid visitors or paid day visitors are in red. The green ones are the international visitors. The purple ones are wildcard owners. And the blue ones are what they call membership. What is interesting here, you see during the COVID period, 2021, 22, the green basically disappears there. And that's your international visitors. Here I've got data on numbers of international visitors visiting South Africa, nice corresponding to the same period as we see here, nice growth in the number of international visitors. Whoops, we had COVID, and basically people stopped coming to this country. There's been a strong recovery in international visitors. This is last year. This year's numbers, I believe, are somewhere up there, maybe even going to exceed what we saw in 2018, 2019. So you can see that recovery in the international visitors there, green coming back in this latest year, 22, 23. But for some reason, numbers of visitors are now about half of what they were in 2016, 2017. For me, that's concerning. Tourism is enormously important in this area. It contributes somewhere in the order 20% of the GDP to the economy in this area. So we need to understand this. We need to know why. Hopefully it's not because people's perceptions of Saldanha Bay, Langebaan Lagoon, the health of the bay is going down. No, I don't think so. We do know that a large proportion of the tourists here are locals. Locals being local South African people. So they account for most of the visitors to this area. It's not the internationals. They only make up a very small percentage. And so why are local people not visiting Saldanha as much as they used to? I think the global economy has recovered a lot, but our South African economy is still lagging behind quite severely, and I think that's why people just don't have money to come on holiday here. Next slide, please. Mariculture production, I said that's gone up, and you can see very clearly here we've got data on mariculture production, both mussel production. The main species that are produced in the bay here are mussels on the left here, and oysters in the green there. Mussel production, we've got data from around 2000, where it started off at about 500 tons per year, stayed constant for a long time up to about 2011, and then suddenly started increasing. Now we're sitting at about 3,500 tons of mussels produced in the bay per year. That's quite a substantial increase, 10, 15 times increase on what it was back in the day. Oyster production, slightly different pattern, very, very slow increase over that period, but it is an increase. It is contributing to the economy of the bay, and I think that is a good thing. There's been quite a lot of work done, both in the past, on the impacts of mariculture on the bay. There was a study done in the 1999 by Jeannie Stenton-Dozy, and then a renewed focus now in the last 2-3 years looking at the impacts of aquaculture on the bay. I'm glad to say that for the most part, the aquaculture industry, although it does occupy a lot of space here, isn't having a hugely significant impact on the bay. There are impacts on water quality in the bay, particularly oxygen levels, which I'll talk about now. And there are some impacts, tend to be quite localized on the benthic environment underneath the raft, but the impacts are quite localized. And from what Simon was saying earlier about whale entanglements, thankfully we don't seem to have many whale entanglements in Saldanha Bay. So luckily, I think from an aquaculture perspective, it's growing, it's contributing to the economy, and doesn't seem to be significantly damaging the bay. Next slide, please. Groundwater is something we started focusing on a little while ago. We know that Saldanha Bay area is a very water scarce area. The gentleman, Eldridge, I think his name was, spoke earlier about concerns around freshwater supply here. Most of the fresh water in Saldanha comes from the Berg River. There's very few natural surface water resources in this area. So groundwater is naturally a very important resource. Historically, there's been a lot of uncertainty and a dearth of knowledge on groundwater resources in this bay, whether groundwater exploitation is sustainable or not. And thanks to the work of Julian Conrad and his team at GEOS and various other people, we've got a lot better handle on groundwater resources in this area, the importance and how much groundwater we can sustainably take away. Most of the most significant groundwater user in the Saldanha Bay area is the agricultural sector, farmers using groundwater to irrigate crops or for whatever they do, taking about 1.5 million cubic meters of water per annum. But there are other very important potential users of groundwater in this area. The one is the municipality. Saldanha Bay Municipality has 2 significant well fields which they've recently set up on the Langebaan Road Aquifer well field, which has the capacity to abstract about 5.1 million cubic meters of groundwater per annum. And the Hopefield well field, which has the capacity to abstract about 1.6 million cubic meters per year. Those aren't operated permanently. Those are drought measures to be invoked during a period of drought when Saldanha Bay cannot access the water it needs from the Berg River. So it's an emergency measure, and it's something that will be invoked, I'm sure, in the future when we go into the next drought, next water crisis. The other important user of water in this area is the Elandsfontein phosphate mine. Lives down there at the bottom of Langebaan Lagoon. I was particularly concerned. I think a lot of people were concerned about the potential impacts they would have on groundwater flows in this area. Elandsfontein abstracts a lot of groundwater in order to dewater its mining pit to enable it to mine the phosphate ore which is on top of the bedrock. But all of the water that they abstract gets re-injected into the well field downstream of where they're impacting. And what we see there, particularly on the work that Julian's doing and the monitoring work that Elandsfontein is doing, is that program has been to date highly successful and is not affecting groundwater flow to Langebaan Lagoon, which is fantastic. Groundwater flow to Langebaan Lagoon is critically important for maintaining the health of that system, and I'll talk a little bit more about that just now. What we're seeing at the moment, the recent work suggests that the sustainable, usable groundwater reserve is somewhere in the order of 15.2 million cubic meters per annum. So that's substantially less than if you add those 3 numbers together. You'll see that there's substantially more groundwater potentially available that they think would be sustainable. So I think we're on a good footing here. I think we're quite safe. And in fact, recent observations suggest that groundwater levels are improving quite nicely in this area. We've had some really, really nice rainfall. This is rainfall records since 2017. That was the peak of the drought, around 200 millimeters in that year, going up slightly 2018. Average rainfall is at about 320 millimeters per year. And you can see the last 4 years have all been above average rainfall. I don't think I need to tell you that. You live here, you've felt the rain. We've had some tremendous rainfall in the last few years. And that has fed through to recharging the aquifers in this area, which is fantastic because it's not going to last. I can assure you of that. We're going to go back into a drought sometime in the future. We're going to need to start using those groundwater reserves, and we need to just be careful, cognizant, and use them in a responsible way. Next slide, please. I said we look at other physical variables and elements in the bay, one of which is wave action. Wave action is something very interesting and something I want to spend a little bit of time on this morning because there's some really new interesting insights we've gained here. What we do know about wave action, those are two wave roses up there showing typical wave energy and path. It's coming up from the Southern Ocean. Waves in this area are generated by cold fronts that move through past south of Africa, generate waves that come up towards Saldanha, and they're tracking up from a southwesterly direction. All of the big waves come from down the southwest there, and they enter Saldanha Bay. They go through the entrance of the bay there, and they refract. They move. As they go through this narrow entrance in the bay, they bend outwards towards the perimeter of the bay. And what happens during that process is that energy that was concentrated around there gets spread over a much wider area. So as you go towards the edges of the bay, they tend to get more sheltered. Wave energy goes down and you get much more sheltered. So you end up with a situation where you've got a very sheltered area in Small Bay, obviously contributed by the development of the causeway, which was designed to protect the iron ore terminal. Also, the iron ore terminal there results in very low wave energy there, and obviously very similar low wave energy in Langebaan Lagoon because the wave action has to refract almost 180 degrees before it gets down there. And quite high wave energy at the entrance of the bay directly opposite where those waves are coming from. Now, we've been looking at data that is produced by the European Centre for Medium-Term Climate Forecasting. They use remote sensing or satellite data to monitor what's going on in the ocean and the atmosphere. We've got some really clever satellites out there. They're able to measure very accurately sea surface temperature, wave action, and they've built the global climate models that we use for forecasting, for our weather forecasting at the moment. And what they're doing with those global climate models is they're starting to hindcast. So they're starting to project backwards to understand how climate has changed in the past up towards the present day. And what we've got from these global climate models now is data on wave energy. And we use something called significant wave height, which is the average height of the highest 1/3 of ocean waves. So if you imagine all the waves in the ocean, pick the highest 3 and the average of that, how has that changed over time? And with this data from the European Climate Medium-Term Weather Forecasting Centre, we've got data for every decade going back to the 1960s now. And the pattern is incredible. The data suggests that back in the 1960s, maximum significant wave height was averaging at about 4.18 meters. And projected going forward, we're now at a level of about 6.24 meters. That's 2 meters. The average significant wave height has gone up by nearly 2 meters in the last 50 years. Sorry, not 50 years, that's 60 years. And you can see how it climbs, 4.185, 5.96, 5.4, 5.8, 6.1, 6.24. That's a massive increase in wave energy in this area. And I've just made some spectral, also sort of histogram diagrams showing how that wave energy, the blue one is from the 1960s, 1970s is red, orange 80, green 90 towards 2000, and I think the 2000 one is this light turquoise one there. So very clear increase in wave energy in this area. Next slide, please. And that's having quite a significant impact on shoreline erosion in this area. Most of you, those of you who live here, are familiar with the groins on Langebaan Beach. Historically, there was a massive problem with shoreline erosion along this area of Langebaan with infrastructure falling into the sea. We were very fortunate. The municipality had funded a beach monitoring program where they had a surveyor who would survey every year, I think about 40 different transects across the beaches. We divided it into Langebaan North Beach, which is this block over here, and Langebaan South Beach. And unfortunately, when I compiled the graph, I switched the two over. So Langebaan North Beach up there is the gray line over here. And basically what this line here is beach width over time. And this is from the 1990, I think it's 1998 at the start there, towards the present day. And you can see what happened to the shoreline there. We've got massive shoreline erosion happening up until about 2000, where I think nearly 200-300 meters of beach of shoreline was lost over that period. Shoreline retreating at a massive rate over there. You'll see here the first municipality decided to take action. People's houses were being at risk. People's houses were falling in the sea because the shoreline here was eroding. So they undertook a program building groins. First groin was constructed in early 2000, I think that's 2004. Second groin was constructed in about 2007. There was also a big program of beach nourishment when they dredged sediment offshore here, dumped it on the beach, and it was very successful. You can see what happened to the beach there. It started to accrete again. So in other words, it started moving outwards again. And basically saved the situation. And since that time, it's been pretty much stable. It's nowhere near where it was back in the 1980s, but at least it's been stable. And those data, unfortunately, stopped in 2019. We don't know what's happening there now. Very interestingly, on Langebaan South Beach, the reverse pattern happened. So that beach actually accreted slightly. So what was happening here was sand was being taken off this beach, taken offshore, and some of it was being put back on Langebaan South Beach, but not nearly as much as was going away. And as soon as those groins were put in place, that beach went back towards where it was previously. Again, next slide, please. Those of you that live here know we had some really, really severe storms this winter. There's been massive damage on the beaches in and around Langebaan. I've got some photographs, thanks to Christo van Wyk, of part of the beach just next to Club Mykonos there. This is what it looks like. That beach used to be at the foot of the ladder there before this winter happened. Now we've lost an enormous amount of sand there. I don't know what's happening on Langebaan North-South Beach. There's a lot of rubble that's been put on the beach there to try and protect that coastline. Potentially some of that wave energy has now been deflected further north, and that's why we're seeing such erosion here. It's a huge concern. It's with that increase in wave energy, it's playing out in huge damage to the beaches. Next slide, please. Also, beaches, 16-mile beach outside Langebaan Lagoon here, out along the west coast edge there. This is 16-mile beach here. There's a group of researchers led by a fellow Dr. Murray from the Wits University, also colleagues from the University of the Free State. They've been monitoring changes in this beach over a similar period, well, much longer period from 1940 up to the present day using satellite imagery. And what they found is unfortunately very similar to what we're seeing inside Saldanha Bay. These graphs, well, let's just look at the scale bar on the right-hand side here. That dark red is shoreline erosion of 100 meters or more, going through to 0 on the white. And then there's accretion of up to about 70 meters in the dark blue there. And if you look at the pattern over here, 1940, so they looked at decadal changes. So the first decadal period, 1950 to 1960, then 60 to 70, 70 to 80, etc., going towards the present day. I want you to focus on that last column there. It's almost entirely red. And there's lots of dark red patches there, which suggest that this beach, this 16-mile beach, has eroded by 100 meters or more in the last 10 years. That's quite serious. The barrier between Langebaan Lagoon and 16-mile beach is not very wide. We're seeing massive shoreline erosion here, and it's something that we need to be aware of. We need to think about how we're going to address it going forward, because if this carries on, it's not going to be long before that breaches. We're losing infrastructure in Langebaan. We're losing houses. It's going to be a problem very soon. Next slide, please. Okay, moving on to water quality. This is some data on temperature monitoring we're doing in Small Bay. We've had what we call a thermistor chain at a little spot here called North Buoy in Small Bay. A thermistor chain is a series of little instruments that measure water temperature, and we've got them strung up through the water column, so it's a vertical line with one at the bottom at around 12 meters and then one a little bit higher up, and a series of them in the water column. And these are the data that they feed back to us. We've been working on this since 2014. We've had this thermistor array in the water. And the different colors on this graph are from the different instruments. So the one that right at the surface there is the very top one, a sort of dark purple color. And the one at the bottom there is the very light blue color at the bottom there. And we've had a few problems where ships have ridden over our thermistor array and either pulled it out the water or chopped the top off. So sometimes where you don't see colors on the top there, that's actually because we lost one of our thermistors, and there at the bottom we've lost data because our bottom thermistor stopped working. But we've got some really interesting patterns and information. It's yielded enormous amount of very interesting information on how the physical system in Saldanha Bay is working. And you see a very nice, interesting seasonal pattern here, this kind of wavy pattern here. What's happening here, where the lines are very close together and all on top of each other, that's during the winter period. And then during summer, you see a huge separation between the temperature on the bottom and the temperature at the surface. But there's also a lot more variability in the temperature during summer as opposed to winter. Winter temperature is fairly constant in the bay, right through the water column at around 12, 13 degrees Celsius. But in summer, you can see temperature varies from about 20 degrees at the surface down to about 8 or 10 degrees on the bottom. And that is mostly linked to a process known as upwelling, where southeasterly wind blows parallel to the shore past Saldanha Bay, tends to drive surface waters offshore. It draws surface water out of Saldanha Bay, and that's replaced by water from the deep ocean that moves in along the bottom. So that water coming in on the bottom is very cold because it doesn't get into contact with the sun. So it tends to come in very cold. And the upwelling also tends to be pulsed. You get a few days, 5 to 7 days of strong southeaster, and then the wind relaxes. So what happens is you get a period of strong upwelling where you get lots of cold water moving into the bay, and it tends to stratify where you get the cold water stuck on the bottom, some warm water left on the surface that's warmed by the sun, and you get what you call a thermocline, where you get an abrupt change in temperature as you go down through the water column. And then when the wind stops blowing, that all relaxes, the water starts to mix up and the whole bay gets cold. And so that causes that very noisy pattern. And you see it, so you get a very noisy pattern during summer where you get that very strong stratification, and then goes through to winter where stratification dies down, the water column is well mixed. And it's also very interesting because it helps us to understand why marine organisms are doing different things. It governs spawning patterns by fish in the bay, spawning patterns, migration patterns, bird feeding patterns. It's all very interesting. It also drives oxygen levels in the bay, because when the upwelling draws in that deep water, the water from the deep ocean, it's very low in oxygen. So we get a lot of, the bottom waters in Saldanha Bay tend to be very low in oxygen because it's often coming from the deep ocean, whereas the surface waters tend to be much better oxygenated. Do you want to go on to the next slide? And this shows some of the data we've got on oxygen levels in the bay. It's thanks to the Department of Forestry, Fishery and Environment from their Aquaculture Development Zone monitoring program. And they are measuring oxygen in 4 places in the bay. We've got oxygen sensors that sit on the bottom of the bay. 2 of those are in Small Bay, the red dot and the blue dot there. And then 2 of them are in Big Bay, another red dot and another blue dot. The blue dots are what we call reference or control stations, and they are located as far as possible from the mariculture infrastructure, and the red dots are located directly under the mariculture infrastructure. And what we're trying to do there is to try and understand what impact does mussel rafts, oyster longlines have on oxygen levels in the bay. And when we look at oxygen in the bay, oxygen in the sea can vary from 0, where there's absolutely no oxygen, up to 8 or 9 milligrams per liter, where we say it's oxygen saturated. That's about as much oxygen that will ever dissolve in the water. And this is data from 2020 towards 2023, and you can see a nice seasonal pattern in the oxygen levels in the bay there. We tend to divide, when we talk about oxygen levels in the sea, we divide it into 3 levels, where we talk about where there's lots of oxygen in the water is mostly saturated, there's plenty of oxygen available for living organisms. That's at a level of about 4 milligrams per liter. So anything above 4 milligrams per liter we say is oxic. It's great, everything loves it, it's good for all organisms. Hypoxic is when oxygen levels are starting to become low, between 2 and 4 milligrams per liter. You can think about climbing Mount Everest, and you're about halfway up Everest, the air's starting to get a bit thin, and you're thinking about getting your oxygen cylinder out. There's not quite enough oxygen to sustain life. If you spend too long in those sort of conditions, or you're not specifically adapted for low oxygen conditions like some of the people that live in Tibet are, you're going to start struggling, and you're probably going to die if you spend too long in those conditions. And then you get a level where we talk about anoxic, where there's pretty much zero oxygen, and that's less than 2 milligrams per liter. That's on top of Mount Everest. And as most of you will know, if you spend more than a few days on the top of Mount Everest, you're not going to come back again. So, and unless you very carefully, specifically adapted to that. Some marine organisms are adapted to very low oxygen levels. And what we see in Saldanha Bay is that during summertime, this is summer, this is winter. During summer, when you get a lot of upwelling, deep ocean water gets drawn into the bay, oxygen levels tend to go down very low, and it's a natural phenomenon. During winter, when the wind's mostly blowing from the west or the northwest, lots of wave action turning over, a lot of oxygen in the water column mixes all the way down to the bottom, and conditions are mostly nice and oxic. So it's a natural pattern. Saldanha Bay, or bottom waters in Saldanha Bay, are naturally low in oxygen a lot of the time. And that goes for Big Bay and Small Bay, and those are the control stations I spoke about, and the patterns in those two areas are very similar. If we compare that to what's going on at what we call the mussel farm stations, those are underneath the mussel rafts and the oyster long lines. In Big Bay, you struggle to see a difference between those two pictures. Mussel rafts, or the aquaculture infrastructure in Big Bay, is having very little impact on oxygen levels in the bay. In Small Bay, the situation is a bit different. There's much more aquaculture infrastructure concentrated in Small Bay, and it's having a noticeable effect on oxygen levels. You can just look at how much time the conditions were anoxic during that period versus over there, and you can see there's significantly more time when the conditions were anoxic there, and equally there versus there. So yes, aquaculture infrastructure, the mussels, the oysters are using up oxygen. It's mostly the feces, the material that is dropped off the rafts that settles on the bottom, decomposes, uses up the oxygen. It is having some impact, but it's not huge. Those effects are not that significant.